Alright class, this is Xerxes, and he's going to be driving me berserk. Here he is, laying on the bar. He's huge. Let me see if I can get him all. He's absolutely a massive cat. And he won't leave me alone. Say hi, Xerxes. Okay. Fast Friday. Stop, Xerxes. Wrong way. Hope you didn't get car sick just then. Today we're going to do kind of Algebra 2 stuff, so you might like that. It's, seriously, I'm not lying, it's Algebra 2 stuff. You're going to do algebraic operations of functions and perform composition of functions. This isn't an assignment where we've got to do all of them because there's not very many. So I'll be pulling some of the examples from the actual text, not the assignment. So, Fast Friday, I'll try to hurry. So basically, let's start out with adding, subtracting, multiplying, and dividing fractions. Functions. Probably the most important note I can tell you is be liberal with your parentheses. That's where you're going to make the most mistakes, is you're not going to distribute properly. You're definitely going to make mistakes whenever you try to distribute a negative sign. You have to be liberal with your parentheses. Given, man, it's easier than you think. So I think maybe the best way for us to go about doing this is to just do, Xerxes, get off me, is to just do a couple of examples. So, given f of x equals x minus 1 and g of x equals x squared minus 1. Let's go ahead and try to find what we would get if we added them, subtracted them, multiplied them, and divided them. So, first of all, we want to find f plus g of x. And you'll write that like this. You'll say f plus g of x. And it's literally going to be x minus 1 plus x squared minus 1. And I know you really don't need the parentheses when you're doing addition, but it's a nice habit to get into. And so then you be sure to distribute the addition sign, which doesn't change anything, and write it in descending order. You get x squared plus x minus 2. Final answer. That's all there is to it. So then when we do f minus g of x, we would have x minus 1 minus x squared minus 1. And so this time when you distribute the negative sign, I'm going to go ahead and write it out. We get something completely different. Now we get negative x squared plus x. So a completely different answer than we did with the addition. But what I really want you to see is that just like with your other real numbers, only addition and multiplication were commutative, meaning the order didn't matter. If we did g minus f of x, we would get a different answer. So then we would have x squared minus 1 minus x minus 1. And this time, let's go ahead and distribute first. We have x squared minus x. Notice that those are different. So it does make order matters. And whichever one they tell you first is the one you're adding first, or subtracting, or multiplying, or dividing. So let's go ahead and multiply and divide these. And multiplication and division multiplication is commutative. So f times g of x will be the same thing as g times, I'll go ahead and write that, will be the same thing as g times f of x. Those are going to equal. In fact, the way they would say it in math, they would say commutative property holds for multiplication. That's what they would say in math. So here we've got, either way, we would have x minus 1. That's my other cat. That's real exciting. They just knocked something out. X squared minus 1. Hello, Sassy. You guys got to meet Sassy. Let me see if you can see Sassy. Hello, Sassy. Say hi. Okay, never mind. That's too difficult, and I don't want to make you car sick. But now she's mad because Xerxes is up here, and they both love their mama. It's kind of dumb. I'm not the cat lady, I promise. No more cats after these guys die. Shouldn't have messed with my camera. So go ahead and FOIL it. We have x cubed minus x squared plus 1. Double check it. X cubed minus x squared plus 1. Write it in descending order. It's just, I wouldn't count it wrong, but it's the mathematically correct thing to do. Okay? F divided by g of x is not commutative. So we'll do both of those. So when we start with this guy, x minus 1 divided by x squared minus 1. You should have gotten real excited just then. I did. Because it would have simplified. You could have changed that to x minus 1 over x minus 1 times x plus 1. Wah-ha! Equals 1 over x plus 1. But you did have a domain restriction from the very beginning. So from the very beginning, you would have had to say that you knew that x could not equal plus or minus 1. That's a domain restriction that would go with your answer. So it's completely different if we did g of f over x. We would have x squared minus 1 on top of the x minus 1. And this time, again, factor the difference of squares. And you get x plus 1. Now your final function does not have a restriction, but the fact of the matter is you started out with a restriction this time of only x cannot equal 1, not plus and minus 1. The only thing that caused this denominator not to work was a positive 1. So it's not too tough when you're adding and subtracting these. Let me see what other kind we have as far as addition and subtraction go. And I think I need to stress that too, is this is a new camera, so it's taking a little bit to get used to. Come on, focus. Is your restriction is decided from the input, from your function you have in your original denominator. So even though we didn't end up with a variable in the denominator, we still would have had it undefined from the beginning, so we do have to state that restriction. Okay? I'm going to hit pause for a minute and try to get rid of some of these cats and fix this camera. Okay. So let's do number 8. I know it's one of them I'll assign to you, but let's go ahead and do it anyway so we can just practice on another one, okay? So, because this one's a little tougher. So let's do f plus g of x. So we've got 1 over x minus 4 plus 1 over 6 minus x. And remember that something's not completely simplified as long as there's two fractions that could still be added together. So we have to make this into one fraction. So it gets a little hairy. I would rather look at this as 1 over x minus 4 minus 1 over x minus 6. And what I've done is I've pulled the negative sign out, and that was a negative x, now it's positive x, and it was a positive 6, now it's a negative 6. And that just makes it a little easier for me to see the factors that I need to multiply by. In order to get them to be the same, I'm going to rewrite the whole thing. I would have to take the 1 over x minus 4 times x minus 6 over x minus 6. Be liberal with your parentheses. Minus the 1 over x minus 6 times an x minus 4 times an x minus 4. And what I end up with is x minus 6 in the numerator minus x minus negative 4, so that makes it plus 4, all over x minus 6 x minus 4. That was sassy. I'm surprised she didn't fall. She's really dumb. So we end up with final answer, negative 2 over, and it didn't matter whether you multiplied that out or not. You could have written it as, you could have written x minus 6, x minus 4, or x squared minus 10x plus 24. Okay? Let's do addition. F minus g of x. Now, this one's going to look very similar to it, and I don't know why that's not focusing. This one's going to look very similar to it, except for this minus. When I pulled the minus out and rearranged this and it became a negative, it's actually going to become a positive. So we'll have 1 over x minus 4 minus 1 over 6 minus x, which would become 1 over x minus 4 plus 1 over x plus 6 minus 6. Then follow the same chain of thought as far as multiplying. This one's going to be multiplied by x minus 6 over x minus 6, liberal with parentheses. This one's going to be multiplied by x minus 4 over x minus 4. And we end up with x minus 6 plus x plus negative 4 over x minus 6, x minus 4. Combine like terms, and we get 2x minus 10 over x minus 6, x minus 4. Again, it's up to you whether you want to multiply them out. I haven't looked at the answers to see how they go ahead and do it. So, okay. Let's see if we can get the multiplication and division done on this page. I hope. F times g of x, 1 over x minus 4 times 1 over 6 minus x equals 1 over, and then just FOIL it. I'll go ahead and write it out just by using the FOIL steps. 6x minus x squared minus 24 plus 4x. Check your work. 6x minus x squared minus 24 plus 4x equals 1 over negative x squared plus 10x minus 24. Domain restriction, x cannot equal 4 or 6. Whoa, get that off my face. Thank you. Sorry about that, kiddos. You didn't need to see that. So let's do one more real quick. All those had the domain restriction. X couldn't be a 4 or a 6. So we'll do one more, and then I'm going to hit pause. F divided by G of X. So X minus 4 all over 1 over 6 minus X. So just remember your rules from 5th grade, 4th, 5th grade. First fraction, change divide to times, flip the second one over, and you are done. 6 minus X over X minus 4. So that, my friends, is just algebraic operations on functions. And then we're going to do composition of functions. But my husband just walked in. See ya.